over 2, u equals to 0, 3, negative 2, v equals to negative 1, 1, 0. And first question is 2u plus v. That's easy. It's just twice this, which is 0, 6, negative 4, plus negative 1, 1, 0, so that you get negative 1, 7, and negative 4. And if you want the magnitude, just take the norm, which is square root negative 1 squared plus 7 squared plus negative 4 squared, which is 1 plus 49 plus 16. That's square root of 66. Second question. So the first question was to find 2u plus v and its magnitude. Second question is, what's the angle between theta between u and v? For this, you want to make use of the two different definitions of the dot product. So here's the first definition of the dot product, which is you multiply their magnitudes and then multiply the cosine of the angle between. But also, if you have coordinates, you don't use this formula at all. You rather use coordinate-wise multiplication and then addition of those. Okay, so x coordinates multiplied together, 0 times negative 1, 3 times 1, and then negative 2 times 0. So x coordinates multiply, y coordinates multiply, z coordinates multiply, and then you add them up. That's how you calculate dot product between two vectors, right? And then that's equal to, that's 0, so it's just 3. Now, then try to see what this formula is telling us. See, you have a 3 here. If I plug that back in here, see, u dot v is 3, that we know. Then we have the following identity, that 3 is equal to the norm of u times norm of v times cosine of theta. And then you have norm of u, which is square root of 0 squared, 3 squared, negative 2 squared. 3 squared plus negative 2 squared times norm of v, which is negative 1 squared plus 1 squared plus 0 squared times cosine of theta. And we like this because once we compute these, the only thing that you don't know is cosine of theta. And theta is what we're going after. So we can solve this for theta and find what angle theta is. And that's how you make use of the dot product to find the angle between two vectors. There's a
in the code, the cosine and
yeah. So let's see. This is 3. 9 plus 4, that's square root of 13, times square root of 2, cosine of theta. And these two multiply to square root of 26, and dividing it to the other side, you have 3 over square root of 26 equal to cosine of theta, so that theta is the arc cosine, the cosine inverse, of this value, 3 over square root of 26. Okay, that's how you find the angle. Now, in general, here's what's always true. You can take this and just solve for theta to get the following identity. So first you can divide by the norm, so you get that cosine of theta is equal to u dot v over norm of u times norm of v. And then to get the theta, you have to do theta equals the cosine inverse of u dot v over norm of u, norm of v. So you can think of this as the formula to use. And you may just, when you're being asked for the angle between two vectors, one nice way is to just use this formula. Okay. Now, seeing this, question C asks, is this angle less than 90 degrees, exactly 90 degrees, or more than 90 degrees?
Less than.
Less than. How do you know that?
Is 3 divided by 2. That's square root 26.
Is what?
Less than 1.
No, that's not. Yes? Is this less than 0 or more than 0? It's positive. There's no negative sign, right? Okay. If this is positive, then you know that the angle is less than 90 degrees. Okay. See, if you draw the cosine graph, here's how the cosine graph looks like. Cosine, here's 360. Here's 180. Here's 90. Here's 270. Cosines start from 1, right? So it goes down like that. And cosine inverse produces values from here until there. So always cosine of any angle is between -1 and 1. But moreover, you can see that when cosine of theta is 0, that means it's exactly 90 degrees. If cosine theta is more than 0, if it's positive, it's over here, which means it's less than 90 degrees. When it falls under the x-axis, that means the value of the cosine is negative. When does that happen? When your angle is between 90 to 180 degrees. Okay? So we know that this is the case where cosine theta produces something positive. Therefore, we can say that the angle theta is less than 90 degrees. Or another way to say it is it's an acute angle rather than an obtuse angle. Okay, D, let's go back here. D asks for the cross product. Let's see, D, U cross V. How do you do that? Well, that's I, J, K. And you have to write these vectors here, 0, 3, -2, -1, 1, 0. And you can either do a row expansion, or you can also do another method, which is to copy this first two column right next to it. It doesn't matter which method you use, you'll always get the same answer, but I just wanted to show you how this method works. Okay? So what you do is you write the first two columns again, and then you take triples. Okay? You multiply diagonally whenever you have triples. So these are not good because this only has 2 elements. This is 1 element. Only when you have 3 of them multiplied together, you're going to multiply. And then you also do that for the other diagonal. All right, so let's do that. I times 3 times 0 is, every time 0 is multiplied, it's just 0. J times -1 is positive 2j. K times 0 times 1 is just 0. K times 3 times -1 is -3k. I times negative times 1 is -2i. J times 0 is 0. Okay. And then what you do is, after doing all this computation, you do right minus left. Okay, so you're going to get 0 plus 2j plus 0 minus, put a parenthesis and put everything here. -3k minus 2i plus 0. And then if you distribute the minus sign, that's 2i plus 2j plus 3k. Right? So that's your cross product. If you are asked to write in coordinate form, you should change this into 2, 2, 3. And please, when you have IJKs, make it a habit to first change it to this coordinate form, because I found out that a lot of students get confused with this use of ij and k. They think that's a number, that those are vectors. Okay. Now, E asks for the area of triangle that has U and V as sides. That has U and V as its two sides. Now, how do you handle such a thing? You have to know that the geometric meaning of the cross product is that if you have two vectors U and V, first you're supposed to find the area of the parallelogram made up by U and V, and then you give it a direction that's perpendicular to U and V. You call this W, right? So if you have U cross V as, oh, let's not use W because I'm going to use it for something else later. Let's just say this is some vector C cross product. Okay, so this cross product has the meaning that its magnitude, the C's magnitude, is the area of the parallelogram, and C is perpendicular to both U and V, given by the right-hand rule, right? So that's the geometric meaning of the cross product, right? Therefore, taking the norm of U cross V, which is 2, 2, 3, and we just computed it, right? So if I take the norm of 2, 2, 3, what's the meaning of this? What does this say? Taking the norm gives us the area of, that's the geometric meaning, right? The way you compute it is by square summing, right? And then taking the square root. So that's 4, 4, 9, so it's the square root of 17. And square root of 17 is the area of the parallelogram built by U and V. Now, going back to this question, what does this have anything to do with this question? Yeah, half of the parallelogram is the triangle, right? See, the triangle built by U and V in this picture is really talking about this triangle. What's the area of this triangle? It's half of the parallelogram, right? So the answer is just half of that, 1/2 of square root of 17. That's the answer. Okay. Now question F is the following. F says if W is another vector that's given as 2I minus k, find the volume of the parallelepiped. I said parallelepiped is like a slanted box, right? Volume of the parallelepiped given by U, V, and also W. Now we learned this as the triple scalar product, or just the determinant. So we know that we're supposed to put this along with the other ones, right? So we just have to put 0, 3, -2, -1, 1, 0. It's, these vectors should be here. And I also have to place this in here. And that's what I meant by knowing how to change this into coordinate form, because if I throw in a couple of these in the exam, the students get completely perplexed about what to do with this because they don't know how this goes in here. You have to know how to change this into the coordinate form. Okay, so what goes here? What? 2, 0, negative 1. Okay, you have to do this first. Okay, and then only then you will be able to put it right here. Okay. Yes.
You already have that vector value, so you can just do the dot product of the vector you just created, W, and just do the dot product instead of doing the whole other matrix.
Right. So Xander's comment is the following. We already have this computed, right? And we know that this is same as saying you want U cross V dotted with W. So often, just computing the determinant is a shortcut because if you were to do this, then you have to first find the cross product and then do the dot product. But in this case, this is a special case where because we already have the cross product, it's actually easier for us to compute the dot product rather than doing the cross product. Yes?
Why wouldn't you have negative 2j for that vector?
Negative 2j?
Yeah.
Because it's minus.
Yeah, it's
Negative.
j times negative 2 times negative 1, so it's positive 2j.
Yeah, and then you
Okay.
subtract the other one from that. You subtract that from the other one, right?
No, it's right minus left.
Oh, okay.
So it's right minus left. So this minus that. Okay.
Okay.
I think you're a little confused because if you use the old method of expanding by the first row, then the checkerboard of signs says it's plus, minus, and plus, right?
Okay.
Try to do it that way and just see that they're the same. Okay? You can see that they give you the exact same answer. Okay?
Okay.
But in here, you don't do plus, minus, plus. That doesn't apply in this method anymore. This is, in a sense, so people like this because you don't have to worry about the checkerboard of signs. You're free to use whatever. Just use the one that's comfortable for you. Okay? But do check that both answers do agree, okay? Or else you probably misunderstood one of the methods. Okay? All right. So going back, rather than doing it this way, I mean, although this is perfectly fine way to compute the triple scalar product, this will be another method you might want to try. So let's do it this way. Okay? So what are we doing? We're trying to do 2, 2, 3, which is the cross product we just calculated over there. And we're trying to do a dot product with W, which is 2I minus K. Okay. We're trying to do the dot product between the two. Okay? Now what would you get? That's what I was saying. That's the standard mistake when I grade the first exam. People would write 4i and then minus 3k. What's wrong with this?
You're missing the J vector, or the J coordinate.
No, j is okay. J is 2j and 0j, so there's no j. Okay. What's wrong with this answer?
Do you not want the I or K?
You don't want I and k. Why is that?
Do the dot product with the vector.
That's why I wanted everyone to do this way first. So change it. If you're given this and asked the dot product, please change it to this form and then compute it. That way you can be sure that you don't make this mistake. Okay? Now there's another reason why this is wrong. Is this a vector or a scalar?
That's a vector.
Yeah, this is a vector, but dot product should be
Scalar.
scalar, so that's wrong. Right? We have a vector which should be a scalar. That's very wrong. Okay? I erased it, but if you recall, the dot product is norm of the first times the norm of the second times the cosine. Norms are scalars. You shouldn't be getting vectors as the answer. Okay? In fact, this happens so many times that now I have a policy that if you write a vector for a scalar value, right, if you write a vector answer for a scalar, no partial credit. Okay? That's what I'm going to do. Never make this mistake, okay? There will be partial credits for other things, but never make this mistake. When I ask you to do a dot product, you better give me a scalar. Do not give me a vector. That's a very serious mistake, okay? And also, if you're being asked for a cross product, you better give me a vector, because cross products should be giving me a vector, okay? Now this one overall should be a scalar. Why? Because this is a vector, that's a vector, and then doing a dot product gives you a scalar. So never confuse between this. You get me?
Yes.
Always dot product should be scalar.
Yes, sir.
Cross product should be vector, okay? Don't mess this up, please.
Yes, sir.
All right, so if I rewrite this into 2, 0, negative 1, then we see that it's 2 times 2 plus 2 times 0 plus 3 times negative 1, which is 4 minus 3, which is 1. Okay, so the volume of the parallel pipe is 1. Okay, and then G, I have, what's the component of U vector in the V's direction? This is a scalar projection. This is called a scalar projection. What's the formula? You do a dot product. And because you're trying to ask for the component of U, the information of U is the valuable one. And the information of U, V is not valuable. Only the direction of V counts. So we get rid of the direction of V by, we get rid of the magnitude information of V by dividing by the magnitude of V. Okay? That's how you calculate the scalar projection. Let's see, U dot V is, we did that a moment ago. It was 3, right? And the norm of V is square root of 2. Right. Okay, so it's 3 over square root of 2. You might want to multiply right equal to top and bottom to rationalize the denominator. So that's the component. That's the scalar projection. What's a vector projection? Vector projection is same as a scalar projection, but now we're still thinking G. Projection of U onto V is a vector. Projection is a vector where you take the value, the component value that you already have, and multiply it with V over V. Now, if you have any vector and divide it by its size, what kind of vector do you have? You got a unit vector, right? And unit vectors are good because it's easy to resize them to have the specified length. So you take this unit vector, which is a unit vector in the direction of V, and then you make it to have exactly this length. That's the purpose of the projection, okay? So projection is sometimes called the vector projection because not only you want the magnitude, but you also want the direction to be in V's direction. Okay? All right, so let's continue. Therefore, this is negative 1, 1, 0 over 2 times norm of V was square root of 2. So these two cancel, and you have negative 3, 3, 0 after multiplying by 3, and you have to divide by 2. You can write your answer this way, or you can divide everything by 3, 2, and write it this way. Either one is fine. Okay, and then H. Find the vector that's perpendicular to, find a vector that is perpendicular to U and V. We already know one. What is that?
2, 2, 3.
2 to 3, because that's the cross product. Cross product are perpendicular to both U and V, right? So that's the answer. That was easy. And I compute U cross V dotted with V. Now, what's the angle between these two vectors? cross product is, you know, you just answered the question and now I changed it and you
2,
just,
2, 3.
this is 2 to 3, right? What's the angle between 2 to 3 and negative 1, 1, 0? Somebody said something.
90.
Huh?
90.
90, why is that? Because we just said it, right? It's perpendicular, right? Okay, so U cross V is the cross product and it's perpendicular to both U and V. Good? All right, if you have two perpendicular vectors, what's their dot product? 0. There's nothing to calculate, that's it. Or if you want, you can really do the calculation, which I don't promote, but V put it here and V it's here. Oh no, I think it should be in this order. Okay, so you should put 0, 3, negative 2, negative 1, 1, 0, negative 1, 1, 0. So that's what it is, and if you do the calculation of this determinant, you're going to get 0. But there'll be like too much work for such a simple answer.